Alright, yeah, good afternoon everyone. Basically we've been starting from logarithm in today's class. And in our previous classes we talked about indices. So indices is just like some of the rules we use in indices will also be applicable in logarithm. So for example, in our indices we talked about, let's say your y is equals to a raised by x. Now this is an index form. This is an differential equation, mainly because there is an equals to sign. Alright, in writing this in the logarithm format, it becomes, you can write it as x is equals to log, you can say your a y. Now, from this concept now, this is an index form, but we'll be able to change it to what? Using the logarithm format. Now, from this now, we can actually change from logarithm format back to what? Back to indices. How do we do that? Now, in logarithm, this number here is called the main number, which is your y. The one beneath your subscript is called the base. Then you have the real function, let's say your x. So in changing it back to index form, that is changing from logarithm back to index form, this base comes to lift this one up, so it becomes a raised by x, then is equals to y, which gives us the index form of it back. Very, very simple. So we've been able to change from what? From indices to what? To logarithm. So there are some basic laws that guide some of these things we do. So we'll be considering some of the laws we use in logarithm. Let's look at that now. Laws in logarithm. Okay, now let's look at the first law in logarithm. We'll call it the multiplicative law. Meaning whenever you have something like you're multiplying, let's pick our constant a times what? Times b. Now this can be written in the form log a plus log b. So meaning whenever you are given a logarithm expression or equation, meaning log a times b. Now there is no base here, but I should have explained that now. Look at it very well. Whenever no base is given, it's always in base 10. So whenever any base is not written here, it's in base 10. So if you have any expression of this kind, you can split it as what? Log a plus what? Plus log b. That's the first law we'll be considering. Now the second one is when you have a division sign. That is when you have a divided by b. Now when you have something of this form, you can write it in this way. It becomes log a minus log b. You get that? Yes, as simple as that. So we're looking at some of these little principles that will help us in solving questions when we get to the examples. Alright, so let's look at the third law. The third law is when you have something in the form of power. Now let's say you have it. Now, this is the number, that is the main number, is having a power. You can write the whole of this expression as n log x. So what have I done? Now I'm having a power here, so I can bring it backward from this basic principle, and it becomes n log x. So this is basically, we're looking at some of these three laws, and we'll be solving as many problems as possible. So let me add this last one to make the work very, very easier when we get to the example. Whenever you have log, let's call this, let me call it log x base x. Don't forget, I said something earlier, when the base is not given, it's always in base 10. But in this case now, the base is base x. Whenever you are taking the logarithm of a number, and the number is the same thing as its base, is always equals to 1. Do we get that? So whenever you say log 1000 base 1000, it's 1. As simple as that. So let's look at a few examples now. Alright, so we've seen those aspects of laws of logarithm. So let's look at some few examples and see how we can apply some of the laws we've learned so far and solving some of these problems. Now the first question is, you have to simplify this mathematical expression. Taking out the choice of my word, you have to simplify an expression while you solve an equation. So this is a mathematical expression, it's a logarithm expression, so we have to solve it. So in solving the question 1, look at it carefully. You have log 1 over 81 base what? Base 3. In this case now, the base is given specifically. Alright, so the first thing you have to do is that, now that's why indices and logarithm, they go hand in hand. So you can write this one in an index form to make your work very, very easier. So the first thing I have to do is that you can write 81 in an index form. How will you know the base? Because you are dealing with 3, so you can write this 81 such that the number to be raised to what? 3. So meaning I can write this as log my base 3, then I have 1 all over. Now 81 can be written as what? 3 raised to power what? 3 raised to power 4. I believe you still remember that now. Very, very simple. Get? Alright, so you have 3 raised to power 4, and basically from our indices, you can write this as log base 3. I can write all of this as 3 raised to power what? Minus 4. Meaning this 1 over is taking charge of what? Of the negative sign. And basically from this, we are almost done. Now, this power, from the third rule I gave us, I told us that whenever you're having a power, you can easily take it backward. So applying that principle, you can have minus 4 log 3 base what? Base 3. And from the last law I gave us, since the base and number are the same thing, this is what? 1. So log 3 to base 3 is what? 1. So my final answer gives minus 4 times what? Times 1, which gives what? Minus 4. Very, very simple. I think you got that. Alright, so let's look at this simple equation also, the second one. We're given solve log x base what? Base 3 equals to what? Equals to 2. Now this is a mathematical equation. Why? Because it's having an equals to sign, so we have to solve. And in most cases when you are given any question to solve, the next thing that should come to your mind is that the variable, a variable must be given in the question in which you have to find. So we have to find this variable, what? Variable x. So in solving it, since it is log x base 3 equated to a particular constant, let's say 2. So in getting the value for my x, now if you remember the first principle, how I change from what? From indices to what? To logarithm. We are applying that principle here. So meaning my base comes here and lifts up this 2. So we have x is equals to what? 3 raised to power what? 2. Take note, not 2 raised to power 3. You get? So it is this base that comes to this right hand side and lifts this number up. So it becomes x is equals to what? 3 raised to power what? Raised to power 2. And obviously that gives us what? That gives us 9. Very, very simple. Hope you got that? Yes. Alright, so let's look at this last one. You have to simplify this simple mathematical expression. We're given, okay, log 9 minus log 3 plus 1 over 2 log 81 all divided by, you have your 2 log 3. Alright, to make it all very, very easy, the first thing we have to do is that let's see how we can write this simple expression. So I'm going to be taking everything at the back, anything behind this, back to the power. So we're having log 9 minus log 3. Now I'm having half behind here, so you can take it to the back, so it becomes plus log 81 raised to power what? Raised to power 1 over 2 all over, you have your log 3 raised to power 2. Now the essence of doing this way is just for me to get my square root of 81. That's the essence of me doing this way. So basically from here I can still have my log. Now let me write this in an index form. Just follow along. I told you just to get the square root of 81. So you have 3 raised to power 2 minus log 3 plus log. Now whenever you're adding a power in this form, meaning the power is a fraction. So this implies that you're looking for the square root of 81. And the square root of 81 is what? 9. You understand? Yes. Okay, that's square root of 81, which is 9, then divided by, okay. So since I've been able to get this one, I'm having 9, I can write this one as, taking it backward, you have log 3 raised to power what? Raised to power 2. You're getting it? Okay, so from here now, you can also write this 9 to be in form of power. So if you're having log 3 raised to power 2 minus log 3 plus, you can also write this log 9 such that you'll be having this as an index form. Now, why am I writing this? Because I'm having 3 here, I'm having 3 here. This one I can make it as 3 to make everything uniform. You understand? So you have log 3 raised to power what? Raised to power 2. Then divided by, let me still write this one too as log 3 raised to power what? Raised to power 2. So everything is uniform now. You're having log 3, log 3, log 3, this one is log 3. So this one is having a power, so you can bring the power backward. So what we've done so far is that we've been able to find the square root of 81, which is what? Which is 9. So from this now, bringing it backward, we have 2 log 3, okay, minus log 3 plus 2 log 3 divided by what? 2 log 3. Okay, so from here now, take note of something. This one, the base here is 10. This one is in base 10. This one is in base 10. The principle I want to apply here is just like the rule I gave us. They have to be in the same base. If not in the same base, you can't use this. So from this now, I'm having 2 log 3 minus 1 log 3 plus 2 log 3. Since they are in this format, they are having the same base. Take note. So I can say 2 minus 1 plus 2. Where am I saying those values? These 2 here, the quotient of this log 3. So to say minus 1, then plus these 2. So I can say 2 minus 1, that's 1. 1 plus 2, that's 3. So I can write it up this as what? 3 log 3, then divided by what I'm having here, 2 log 3. Let me take kind of recap. Where do I get this 3 from? I said this 2 here minus, there's a 1 here, minus 1, then plus 2. That gave me this 3, then I wrote the denominator. Hope you understand. So from here now, the work is very, very easier. Since I'm having 3 log 3 all over 2 log 3, now this log 3 can cancel log 3 now. You get? So this log 3 cancels log 3. I'm left with what? 3 all over 2. Very, very simple. So from this now, I've been able to simplify this whole complicated expression to what? To a very simplified one. You understand? Okay? So in this case now, that's all about logarithm, in which we'll be doing some examples. So I'll be giving us some few assignments. Okay, let's see this assignment now.